For number 10, we're finding 5 factorial. And a lot of calculators will actually have a factorial button that you can just push. But 5 factorial is also 5 times 4 times 3 times 2 times 1. So you can manually type that in, and the answer is 120. For number 11, another factorial, you can manually do it as 13 times 12 times 11 times 10 all the way down to times 1. But again, most calculators will have that factorial button, so it's quicker just to type 13 and then the factorial button, and you'll get this answer. For number 12, doing a permutation, if you had 6 items and you wanted to see how many ways you could take 5 of those and arrange them in different orders, you would do 6 permutation 5, and the answer is 720. Most calculators have a button where you can do permutations and combinations. You can also try this in StatCrunch. It's a little clunky. I recommend using the internet. If you Google search permutations and combination calculator, the math is fun. That is one of the first things that come up, and it has a great little calculator. It's pretty easy to use. We had 6 items, and we wanted to do permutations on 5 of those. How many different ways could we arrange them in order? So we want order to be important, and that's what gives us permutations, and there's 720 ways. Number 13, calculating another permutation. You'll get the value using your calculator or the internet. For number 14, we're actually shown the 5 items. They're A, B, C, D, and E, the letters. And we're going to do 5 permutation 2. So we're taking 2 of them at a time and arranging them in all the different orders possible. So list out all the different orders that are possible of those letters. And 5 permutation 2, there should be 20 different arrangements of 2 of them at a time. 15, doing a combination, 3 combination 2, and the elements we're using are M, L, and N, the letters. So how many ways can you take 2 of them and form a group? And there's actually only 3 ways to do that. You could have the M and the L, the M and the N, or the L and the N. So we get answer C here. Notice D would be the answer if we were looking for permutations, because they have all the groups of 2, but the order, all the different orders are listed as well. So D would be all the permutations, 3 permutation 2, but for combinations there's just 3 choices. For number 16, we're going to burn a CD with 8 songs, and we want to know how many ways can you arrange the 8 songs on the CD. So the order is very important here. Different ordering will be a different arrangement. So we're taking the 8 songs, and we want to know how many different ways we can arrange. We're going to work with all 8 of them. So 8 permutation 8. And there's this many different ways to arrange the 8 songs in special orders. For number 17, we have a garage door keypad with 5 numbers on it. 1, 2, 3, 4, and 5. And we need to enter the correct 4 digits in the right order to open the garage. How many codes are possible? So anytime you're making choices like this, here we're choosing a number to push, and then another number to push, and then another number to push, and then a 4th number to push. We're making 4 choices. Anytime you're making choices, I want to know how many total possibilities are there. Just multiply the number of options you have for each choice together. So we're choosing a number for the first to push first, and there's 5 options. A number to push second, there's 5 options. There's 5 options for the 3rd number, and 5 options still for the 4th number. Multiply 5 together 4 times, and you get 625 total possibilities you could type in. What's the probability you get the code right on the first try if you forgot it? Well, there's only 1 correct code, and there's 625 total possibilities, so it's 1 out of 625. For number 18, we want to know how many different simple random samples of size 4 can be obtained from a population of size 45. A simple random sample is just a group, so we want to know how many groups of size 4 we can get if we had a population of size 45. So we want 45 combination 4. We want combinations because we're just trying to find groups of size 4. We're not really concerned about the order of the objects in those groups. So 45 combination 4 comes out to that. You can do it on a calculator. 45 combination 4. Order is not important. That's what makes it combinations instead of permutations. For number 19, we surveyed 500 people, and it's determined that 22 out of those 500 play soccer. The probability that a randomly selected person plays soccer Well, imagine if you put all 500 of those names in a hat, there would only be 22 names of people who played soccer. So if you picked one out, you'd have a 22 out of 500 chance of selecting someone who played soccer. So 22 out of 500, 0.044 is your probability. For number 20, a man is taking a standardized test. He's thinking about 12 different colleges he may want to go to, but he is only going to send his score to 2 of those colleges. So how many ways can he pick 2 colleges out of the 12 to send his score to? This is a combination problem because the order doesn't matter. It doesn't matter if he writes down that he wants to send the scores to Harvard and Yale, or if he wrote down Yale and Harvard. The same group of schools would get his test scores no matter what order he lists them in. So we're really just forming groups of 2 here. Order is not important, so you do 12, combination 2, and there's 66 ways. You can do that on a calculator. 12, 2, order is not important, 66 combinations.